Welcome back. Let's do another Thevenin equivalent with test source method because there's really good stuff in these kind of problems here. So we're trying to find the Thevenin equivalent, and we're going to use test source method, which is really to find R sub Thevenin. So R sub Thevenin is test source method. That's what we're going to use to find R sub Thevenin in this problem. And we still need to find V sub Thevenin to get the Thevenin equivalent. And for that, we're going to use node voltage. So there's two main processes to finding a Thevenin equivalent. First, you have to find V sub Thevenin, and we're going to use node voltage. And second, we have to find R sub Thevenin, and we're going to use test source. The circuit that we're given is this guy. These are good problems, these test source things. There's a lot of fun stuff that happens in here. Okay, here's our terminals A, B, which are what we're trying to find the Thevenin equivalent with respect to. 40 ohm resistor, 80 ohm resistor, 4 amp current source, 60 ohm resistor over here, 20 ohm resistor over here, a dependent source given by 160 I delta. And I delta current is the current through this 40 ohm. This is I delta. So whatever this reference current is, this guy will be, this dependent source will be monitoring the I delta current and putting out 160 volts. So here it's monitoring a current but putting out a voltage that's proportional to that current. This is a voltage source. Okay, so the first step to this process here, we're going to use node voltage. And it's good to redraw the circuit because we're doing two separate things here, two separate processes. First, we're finding V sub Thevenin. So we'll redraw the circuit and we'll use node voltage to find V sub Thevenin, which is across here, across the terminals A, B. So we'll redraw this guy. Just because I don't want to scribble all over the original circuit, because I'm going to need that for the second part of this problem. All right, down here at the bottom is V0, or rather 0 volts, 0 volts. And up here, so you've got to label all these guys. Let's see, 80 ohms, 20 ohms, 4 amps, 60 ohms. What's this one? 40 ohms. This is I delta. Okay, what do we got? We're trying to find V Thevenin, which is up here. So we'll label this node V Thevenin. And this is also V Thevenin at this point. It's the same node because there's no device in here. So I like to draw these kind of fat nodes going on like that. And I'll go ahead and label this terminal for convenience. And so node voltage method is the sum of the currents at a node. And we'll use in to be negative and out to be positive. And what we're summing is currents. Sometimes directly currents, and other times we'll be using V over R terms. So over here we'll write the sum of the currents at V Thevenin. So what I need to do is label all the currents on this diagram and come up with expressions for them. So I've got I delta leaving here. That's good. I've got to guess a current on this branch. I've got to guess whether it's coming in or out. And I feel like making it out because I delta is coming out through this 40, and I don't know, it just seems like this guy would be coming out. But you know, it's a guess. And sometimes students have, I found, get a little nervous making guesses, but basically you try and guess correctly, and if you guessed incorrectly, you'll just have a negative sign in there, which is fine. You can deal with that. All right, now we need to guess on this current in this branch here. Yeah, the current in this branch is very, very much a guess. Let's kind of look over here and try and guess this thing a little bit better. You know, there's no real good way to guess which way the currents are going in here. There really isn't. This guy here, well, I'm going to need another node voltage current. That's why I'm over here. I'm going to need another node voltage equation, which isn't obvious at this point, but I'm going to need that. And so I'm kind of guessing on these currents here. This guy's going to be in. Let's guess that this is coming out, and let's guess that there's a current going this way. So that'll be over here. This will be same direction on the other side of this device. So we've got all of these guys. Let's see if we have expressions for these things. So this current here, it's 0 volts here and V7 here. So this guy here is going to be V7 over 80, that current. This guy here is I delta. We can use that. And I delta is also given by V7 over 40, which might be handy later. This guy here, we need an expression for this guy. This is a voltage source here. This is 160 I delta. So if we were starting here at V Thevenin, the voltage at this point is V Thevenin. And if we go across this device, we're rising in voltage by 160 I delta volts. So that's really what's at this point right here. So let me label this node. This node has, go over here and we'll try and label this thing. We're starting at V Thevenin and we're going from minus to plus. So we're rising by this thing, by this 160 over I delta. So the voltage at this node is V Thevenin plus 160 I delta. That's what it is. And that gives us an expression for this current right here. Actually, it doesn't. It just gives us an expression for the voltage at this point. But we would need a resistance in here to figure out this current. All we know is the voltage right now. So we have to kind of look around some more, and that's where this other node comes into play here. So let's label that node. There's 0 all the way across the bottom, and then we're rising by some voltage V. We'll call that guy V. And then we can get an expression for this current right here. Okay, because we know the voltage at this node, we know the voltage at this node, or that is, we have an expression for the voltage at this node, and we have an expression for the voltage at this node, and then I have a resistance. So by Ohm's law, this current is the potential difference over the resistance. It's V minus quantity V Thevenin plus 160 I delta over 20 ohms. Okay, and then this guy right here, it's 0 volts on the bottom and V volts at the top across this resistor here, right? The current through here, which is the same as the current right here, right? This current goes down through here, and the potential difference across this guy is it's V minus 60 over. I'm sorry, V. It's just V. Whoops. This guy here, it's V over 60. It's V volts here and 0 volts here, so the potential is V, and the resistance is 60, so it's V over 60. Okay, we've got expressions for all of these currents, and I can start writing node equations now. So we'll write the sum of the currents at V sub Thevenin. So I've got coming, let's see, coming in here. I've got this current coming into V Thevenin, this current right here. It goes through this device and then into the node. So this guy here is negative because it's coming in, and it's this expression right here. It's negative V minus quantity V Thevenin Thevenin plus 160 I delta over 20. It's a big ugly guy, but that's this thing coming into this V Thevenin node. Then I got these two guys leaving. I've got V Thevenin over 80. This guy leaving, and then I've got I delta leaving, which I've expressed as V Thevenin over 40. Those sum to 0. I got them all coming in, summing the currents coming in and out of V Thevenin. I've got this current coming in, which is negative, and that current quantity is given by this potential difference over this resistor. So I've got the potential at this node V minus potential at this node, this thing, over 20. And then I've got this guy coming out, V Thevenin over 80, and I've got this guy coming in out, V Thevenin over 40. That's the first guy. Okay, there's two unknowns in this equation. There's V Thevenin and V, so I'm going to need another equation. So let's sum of the currents at V and see what we get. Let's sum the currents right here. Okay, coming out, I have this V over 60. It's coming out. I've also got coming out this guy, the same guy up here, but now it's positive because it's coming out. It's going to be V minus V Thevenin plus 160 I delta over 20. It's coming out. This guy's coming in, and this guy here is just 4. Ooh, just a number. Great, 4, because we have given 4 right here. That sums to 0. All right, let me just double check this. This is good. Yeah, that's good. So there's 2 equations and 2 unknowns in here, and I don't want to take the time to solve that because it's already a lot of work just presenting this stuff, but your calculator should be able to solve this, and what it's going to tell you is V is going to be 172.5 volts, and V Thevenin, which is what we want, is 30 volts. Okay, V Thevenin is 30 volts. That's the answer we want there. It's also going to, well, that's all we care about. I mean, I delta would come out of this too. Well, you could plug I delta. You could get I delta if you knew V Thevenin. Anyway, all we really care about is V Thevenin, and we got it. So that's the step 1, or process 1. It's much more than a step, I guess. Let's do process 2, R Thevenin via the test source method. So we're going to start over with our original circuit right here, and we're going to open the I's and short the V's. Let's see if I can do that without messing it up. So this guy stays there, and this guy stays there, and this guy stays there, and this guy stays there. But we open the I's, and there's an I, this 4 amp guy, so he gets opened. And this guy stays there. So the 60 ohm stays there, the 20 ohm stays there, this 160 I delta stays there, the 80 stays there, the 40. And then we hook up a test source, V sub t, because we're using test source method, and we're going to have I sub t going into this node A. And node A is all the way across the top here on these 2 guys. All right, so this is step or process 2. We're trying to find R sub Thevenin via test source, and the test source method tells us to open the I's and short the V's, insert this V sub test, and then we're going to solve for R sub Thevenin is going to be V sub test over I sub test. That's the method. So that's why I left the original circuit nice and pretty, because I wanted to start over at the original circuit to do R sub Thevenin solution here. So for this method here, what we want to do is look around and find an expression for V sub t over I sub t, and that'll give us R sub Thevenin. So you look around and you look around, and This guy looks suspicious. Let's check him out. Let's see. This current here, this I delta, basically, is still given by the voltage and the resistance, but now the voltage is VT. Different problem, right? It's not Thevenin any for this part of it. We're just trying to find R Thevenin here. It's a different problem. So now we're going to use VT over 40 for I delta. And this guy right here is going to be VT over 80. I'm going to squeeze it in here, just right there. VT over 80 is the current right there. And let's see. I test coming in, I delta, which we can express in terms of VT coming out, and this guy, which is VT over 80 coming out. Let's, we got something on this branch here. We got to guess a direction. And just to show you that it still works if you guess incorrectly or you guess differently, let's guess this way on that direction and see if we can get an expression for that. So we know the voltage at this terminal, at terminal A, is VT. That is the, we're still sort of using this as 0 volts down here. We know that the voltage across AB is VT. I mean, you don't, if throwing this 0 on the bottom seems freaky to you, we're just using the voltage across here. So basically, this is VT at this point, and then we're rising from minus to plus by this voltage quantity here, 160 I delta. So the voltage at this terminal is VT plus 160 I delta, and then we're back to 0 volts. So basically, across these two guys is the potential difference, VT plus 160 I delta. So that'll give you this, the current through this branch here. It's going to be VT plus 160 I delta over 60 plus 20. We can write a KCL at node A. We'll use in being positive and out being negative. We'll sum all the currents coming in and out of node A. So I've got I sub t coming in. So there's I sub t coming in. There's this guy coming out, this I delta, which is given by VT over 40 coming out. So this is VT over 40 minus, and then we've got VT over 80 also coming out. These two currents, VT over 40 is this current, VT over 80 is this current. And then this current coming out of node A, so it's negative, is the same current coming all the way around this branch, which is given by Ohm's law, is given by this potential difference over this resistance, this expression right here. VT plus 160 I delta over 60 plus 20. It's ugly, but there it is. And these guys sum to 0. Right? I've got in, out, out, out. VT is across these two guys. And VT minus 160 I delta is across these two guys. That's it. So now all we got to do is solve this big mess for VT over IT, and we've got R sub Thevenin. So here we go, taking this guy right here, let's put IT on one side and bring all the VTs to the other side. So it's going to be VT over 80 plus VT over 40. Just moving those two guys over and then moving this mess over, you're going to get VT plus 160. Okay, I delta is this VT over 40. I'm going to put that in right here. This is VT over 40 because I really want to get rid of I delta over 80. Then what? This is what? VT over 80 plus plus what? You could, well, I got 80, 80. I could make this 80. You know, I could just multiply the top and the bottom times 2, and I get 2 VT over 80, just to have a common denominator. And then I could factor these guys apart. This thing, I could factor it into VT over 80 plus, plus 160 VT over 40. 160 times VT over 40 plus, or over 80. That, which is, let's see, 160 over 40 is 4 VT over 80. This thing turns into 4 VT, and then the other guy is just bringing them down. So I have a whole bunch of things, a whole bunch of over 80s. How many over 80s do I have? I have 8, right? I have 4, 5, 6, 7, 8. So there's 8 VTs over 80. That's how many VTs over 80 I got, which is just VT over 10. So our sub Thevenin is VT over IT. That's what the method says to do, and you know, that's just 10. So answer. I'm trying to find the Thevenin equivalent. So R sub Thevenin, we just solve for that. It's 10 ohms. And V sub Thevenin, we solved for a long time ago. It was like last week, or in internet time. It was 30 from the previous process. Okay. It's about as ugly as these things get. In a fun kind of way. All right. Hope this was helpful to you. See you next time.